Okay, so one of the question is like this. The plane through the intersection of the plane x plus y plus z. Okay, it is twice x plus 3y minus equals to 0 and x plus y plus z is equals to 1 and parallel to y-axis passes through the point option A -3 0 -1, option B -3 1 1, option C 3 and option D 3 2 1. Okay, let's solve it. So here we are having a plane which is passing through the intersection of this plane and this plane and parallel to y-axis. So basically in previous class also we were discussing that how we will get a equation of a plane which is passing through the intersection line of intersection of two plane, and that's equation will look like this one. Plane 1 plus lambda times plane 2 is equals to 0. Yes or no? Right? So here also we are having two plane. This one is the first plane, this one is the second plane. So we can write it like that. We can take plane 1 as a twice x plus 3y minus z plus 4 in one bracket plus lambda times p2. What is p2? X plus y plus z, x plus y plus z minus 1. Okay, this is our equation of plane is equals to 0. So our equation of plane will be, if we will take the coefficients, like x coefficient will be 2 from here and then plus lambda. Y coefficient will be 3, y will be 3 from here and then lambda y. So lambda from z coefficient, if we will take, it will be -1 and from here it is just plus lambda, and the constant will be 4 minus lambda. Is it clear so far? Is it clear so far to everyone? Okay. Now let's see what the question says. So the question says the plane through the intersection of this plane and that plane parallel to y-axis. Okay. So basically this is how our y-axis looks like. Okay. X-axis, y-axis, z-axis. Okay. So y-axis is this one. What we'll do, if we will take if we will take a plane which is parallel to y-axis, basically our plane will look like this one. No? So this is how our plane will look like. a plane which is parallel to y-axis, right? If we will find normal to the plane, normal to this plane, can we say that normal will be normal to y-axis also? Yes or no? Yes or no? Are you getting it? If we will take
Yes.
normal to this plane, that normal will be perpendicular to y-axis also, right? So how we find normal to plane? Normal to this plane will be 2 plus lambda x coefficient with I cap, y coefficient with j cap, z coefficient with k cap. This is normal to the to this plane, the given plane, to our plane which we have created now. Okay, now we will say this is perpendicular to y-axis. So what is the direction ratio of y-axis? Direction ratio of y-axis, it will be 0 1 0, right? So what we do, we do the multiplication and then like direction ratio of y-axis and the direction ratio of normal. If we will do the dot product, that will be 0. Okay, that means we can say that we will be having 3 plus lambda j component over here and j component over there into 1 dot product is equals to 0. Okay, that means it is just 3 plus lambda is equals to 0. Lambda is equals to minus 3. We got the value of lambda from here. Is it clear so far? What we have
Yes,
to
ma'am.
find? We have to find the equation of the plane. Okay, so we got the value of lambda as a negative 3. So our equation of plane will be, this is the equation of the plane we are having. Let's substitute lambda value over there. So we will be having 2 minus 3. Okay, 2 minus 3, that will be minus x minus 1. Here 3 minus 3, it will be 0. 0 into y. Here negative 3, negative 1, negative 4 z. Here negative 3 if we will take, so 4 minus of minus 3, that means 4 plus 3, that means 7 is equals to 0. This is our equation of plane. We can write it as x plus 4z is equals to 7. Okay, now we have to find the equation of plane which we have found through the intersection of this plane, that plane parallel to y-axis. We have taken the condition passes through the point. We have to check our plane which we have got just now, which we have obtained. That plane is passing through which point? Okay, either option A, option B, option C, or option D. So we have to substitute the given point to check. So x plus 4z is equals to 7. That means if we will take this one, the first point, negative 3, negative 1. So negative 3, no, we will not get. Second point, if we will take, so negative 3 and 1, no. I believe both should be positive. If we will take option D, 3, 2, 1. Okay, 3, 2, 1. Will it give 7? If we will take x value as a 3, z value as a 1. Yes, we are getting 7. So option D is the correct option. Is it clear to everyone what we have done here? We have
Yes,
found
ma'am.
the equation of a plane which is passing through the intersection of the given two plane. This is the required format. From here we got the equation of the plane in terms of lambda. We needed to find the value of lambda. Here one condition is given, that is the obtained plane is parallel to y-axis. So we have taken normal to the plane and we are saying that normal will be perpendicular to y-axis. So we are taking the condition, we are doing dot product is equals to 0, and this is what we got equation of a plane, and then we are just searching the option which will, the point which will lie on this plane. Is it clear to everyone? Yes or no?
Yes, ma'am.
Now there is a question which says if the angle theta between, just a second, no? So here the question is, if the angle theta between the line equation of the line is given, the plane equation is also given, is such that sine theta is equals to 1 by 3, then the value of lambda. Then the value of, can you see lambda over here? This lambda value we have to find. Okay. Options are also given over here. That is 5 by 3. Option B is negative 3 by 5. Option C is 3 by 4. And option D is minus 4 by 3. Okay, how we will solve it? So here we are having the angle theta between the line and the plane. So if our plane looks like this, okay, if our plane looks like this and if there is a line on it which is making angle theta, okay, so line, if there is a line like this which is making angle theta with the plane, okay, this is the angle theta, a plane is there, a line is there, okay, a plane we are having and the line is there on the plane, and the line is making angle theta with the plane, okay, the condition is given over here, equation of a line is given, equation of a plane is given, it says that sine theta is given as 1 by 3. So we are not sure how to proceed over here. Sine theta is given, a plane is there, a line is there, can we say here, if we will make the normal to the plane, if we will just make normal to the plane, this normal will make 90-degree with the plane, that we know. Okay. Now, this red angle is theta. The green angle, total angle is 90-degree. So can we say this one is 90 minus theta? Can we say?
Yes.
Yes, we can say this one is 90 minus theta. And we know there is a relation, there is a rule for finding the angle, that is cos theta. Instead of theta, I am going to find the angle between this line. Let's say the line is D and this one. Okay, the normal. So I, instead of theta, I would say cos 90 minus theta is equals to n dot D over magnitude of D, and this is the formula we are having for finding the angle. Yes or no? Do you know this formula? Let me know, do you know this formula
Yes, ma'am.
for finding the angle? So we are going to use this formula I have over here. 90 cos 90 minus theta, you must know that is just positive sine theta. First quadrant, everything is positive. So we will be having normal to the plane. We can find easily. Equation of a line is given. Magnitude of n, magnitude of d. Let's do it. So what we'll be having, equation of a line is given over here, that is x plus 1 by 1, y minus 1 by 2, z minus 2 by 2. So equation of a line is given, x plus 1 by is 1, y minus 1 by 2 is equals to z minus 2 over 2. And the equation of plane is given over here as 2x minus y plus root lambda z. 2x minus y twice x minus y plus root lambda z is equals to 0. Okay, these two equations we are having in hand. Normal, equation of normal to the plane we can find, that is 2y minus z plus under root lambda k. Okay, this is what we are having, equation of a normal. What about this d? D we have taken a vector along the direction of the line. Okay, so a vector along the direction of the line, a vector in the direction of the line, this d will be, direction ratios we will use this one and this one, so it will be I plus 2j plus 2k. Okay, this is what we are having as a d, this is what we are having as a n. Sine theta, from where we got, it was cos 90 minus theta, we have written it as sine theta. Why we have written it as sine theta? Because sine theta is given directly as a 1 by 3, so we will be using this value over here. We will be saying that the left hand side is nothing but just 1 by 3. So let's use that. Here we will be having dot product, we will do, so 2 minus 2 and then 2 into root lambda over under root 1 square plus 2 square plus 2 square, and this one 2 square plus negative 1 square plus this under root lambda square. This is what we are having. Okay, let's solve it. So we will be having 1 by 3 is equals to 2 root lambda will be there in the numerator, and what about the denominator? 449, that means 3 we will be having here, and here under root. Okay, this is what we'll be having here. 3 and 3 will go. What we will be having, if we will just do crisscross, 5 plus lambda will be here, 2 root lambda will be here. If we will do squaring both sides, 5 plus lambda is equals to 2 lambda only, not 2, 4 lambda. Okay, so lambda if we will take to this side, it will be 3 lambda is equals to 5 by 3 we are getting as a lambda value. Let's see. Yes, can you see this option is the correct option? Okay, is it clear to everyone what we did over here?
Yes, ma'am.
Okay, let's move ahead. The next question is a line with the positive direction cosines passes through P 2 negative 1 2 and makes equal angles with the coordinate axis. The line meets the plane bisects plus y 9 at q. The length of a line segment, the length of the segment PQ equals option A 1, option B root 3, option C root 2 and option D 1. Okay, let's see what the question says. A line with a positive direction cosine. A line with positive direction cosine passes through this point and make equal angle with the coordinate axis. So if a line is making equal angle with the coordinate axis, that means alpha, beta, gamma all are same, right? And if alpha, beta, gamma all are same, then what we can say? Can we say that cos square alpha, cos square alpha plus cos square beta plus cos square gamma? Instead of beta and gamma, I am going to write cos square alpha again. Cos square alpha again is equals to 1, right? We can write it because all the angles are same. Alpha, beta, gamma all are same. So instead of beta and gamma, we can write alpha and alpha again and again. Okay. Now if we will simplify it, what we will have? We will be having 3 cos square alpha is equals to 1. That means cos square alpha is equals to 1 by 3. That means cos alpha will be, that means cos alpha will be plus minus 1 by root 3. Let's see what the question says. A line with a positive direction cosine. Okay, so the direction cosine is positive. We have got two possibility, plus and minus. We will be taking the positive one. So we need to take cos alpha is equals to 1 by root 3. Positive 1 by root 3. Okay. So we can say L, M and all are 1 by root 3, 1 by root 3, 1 by root 3. Okay. We can say direction cosines are 1 by root 3, 1 by root 3, 1 by root 3. If we will find the direction ratio, we can multiply root 3 with all of it and we will be having 1, 1, 1 as a direction ratio. Now a line with positive direction cosine passes through this point. So the line is passing through this point and having direction ratio which we have found, which we are saying it will be 1, 1, 1. So 2 minus 1, 2. So the equation of line will look like 1, y minus y1, z minus z1 over the direction ratios we will use, right? This is how our equation of line will look like. If we now what the question says, A line with a positive direction cosine passes through this point and makes equal angle with coordinate axis. This much we have discussed already. We have constructed the equation of a line by using the given condition, obviously. Now the next statement says that the line meet the plane. Okay, so the line meet this plane at Q. Line meet the plane at a point Q. So this point Q is lying on the line, and this point Q is lying on the plane. Okay, this is the point of intersection of the line and the plane. Okay, so if we need to take any random point, let's say that a point Q on this line, so we can say, let's take this as a K or maybe lambda. So the equation will, so X will be K plus 2, Y will be K minus 1, and Z will be K plus 2 again. So our coordinate of a point, let's say coordinate of a point value of K, okay? Coordinate of point Q will be K plus 2, K minus 1, K plus 2. We are taking just a random variable K, and we are saying that the coordinate of a point Q, which is, you can see Q is lying on the line and Q is also lying on the plane. Okay, so this Q which we have got from the line, we can say this Q is lying on the plane also. Q lies on the plane also, so it must satisfy the equation of the plane. Okay, what is the equation of the plane? The equation of the plane is 2x plus y plus z is equals to 9. The equation of the plane is 2x plus y plus z is equals to 9. Here we will substitute the point Q, that is K plus 2. So 2 K plus 2 plus Y will be K minus 1. Z will be again K plus 2 is equals to 9. Okay, so what are we getting from here? 2K plus K, and this 4 minus 1 plus 2. Okay, 4 minus 1 plus 2 is equals to 9. So 2, 3, 4. 4K and 4 minus 1, 3 plus 2, 5 is equals to 9. We are getting 4K is equals to 4. K will be 1. Okay, we got K as a 1. What we have to find here? The length of a segment PQ. Okay, let's find the coordinate of Q then. We got K as a 1. Let's find coordinate of Q. So Q will be K plus 2, that means 2 plus 1, 3. K minus 1, that is 1 minus 1, 0. K plus 2, that means 1 plus 2, that means 3. This is the coordinate of Q. Now it says that the length of the line segment PQ we have to find. P we already know it is 2, negative 1, 2. P we already know it is 2, negative 1, 2. Let's find the distance, the length PQ. X2 minus x2 minus x1 square plus y2 minus y1 plus z1 square by doing it. So what are we getting from here? Do it and let me know. What are you getting as PQ? Please do the calculation.
Root 3.
Okay, root 3 we are getting. Let's see, option is having. Yeah. So we are already having option B as root 3. Everyone getting root 3, right? Let's summarize the concept, what we have done here. So let's read the question. A line with a positive direction cosine passes through this makes an equal angle. So if a line is having if line is making equal angle with the coordinate axis, x-axis, y-axis, z-axis, we are having a relation L square plus m square plus n square is equals to 1. We are using that relation and we got L as a 1 by root 3, m and n both 1 by root 3, 1 by root 3. From there we are getting the direction ratio, that is 1 1 1. Okay, now we are just writing the equation of a line passing through P and having direction ratio. Okay, once we are writing the equation of a line, that line is having a point Q. Okay, that is the intersection point of the plane and the line. So that point Q is lying on the line also and on the plane also. So we are just taking out a random point from the line and we are saying that is Q. Okay, depends upon the value of a K. Now that point is lying on the plane also, so we are just substituting the point and we are saying that it will satisfy the plane. We are getting the value of the unknown and then we are just able to find the length PQ. Is it clear? Is it clear to everyone?
Yes.
Okay, let me take the next question. So the next question is, if the line x minus 2 is equals to y minus 1 by negative 5 is equals to z plus 2 by 2 lie in the plane x plus 3y minus alpha z plus beta, then alpha beta is equals to. Okay, options are negative 6, 7, option B 5, negative 15, option C negative 5, 5, and option D 6, negative 70. Okay, so if a line, this line lie in the plane, we are having a plane. Okay, we are having a plane and a line is lying on that plane. Okay, let's say this is the line we are having. So basically here we are having a plane and the line, the given line is lying on the plane. A plane is there, a plane is there and the line is lying on that. It's like that. Okay. Now we have to find the value of alpha beta. If we will, if we will make, if we will make the normal to the plane, normal to the plane, can we say that normal will be perpendicular to the line also? Can we say? Can we? Yes or no? If we will make, if we will make normal to the plane, okay, normal to the plane, that normal will be perpendicular to the line also. Yes or no? What will be the equation of, like, what will be the normal to this plane? This is the equation of the plane we are having. Normal will be I plus 3 3j minus alpha k, and line means we are talking about a vector which is in the direction of the line. Okay, so we can say this vector will be 3i, this direction ratios we will use. Okay, so that vector will be, let's say d, it will be again 3i cap minus 5j cap plus 2k cap, And since we are just making normal which is perpendicular to this vector also, so we can say that n dot d is equals to 0. Yes or no? Can we say?
Yes, ma'am.
We can say. So a1, a2, b1, b2, c1, c2. Let's do that. So 3 into 1, it's 3, plus 3 into negative 5, 3 into negative 5, plus 2 into negative alpha, plus 2 into negative alpha is equals to 0. From here we are getting a value of alpha. Please find it. What are you getting as a value of alpha?
-6.
Minus 6. Okay, everyone getting the same? We also have to find beta. Equation of the line is given as x minus 2. Let me write here x minus 2 over 3 is equals to
Is it option A? Yeah.
yeah, what?
Option A.
Oh yeah, without even finding beta, we are able to find the option. It's option A. Yes, because minus 6 we are just getting in option A, so it is the correct option. Still, if you want to be sure, you can go ahead and you can check for beta. How we will be checking for beta? Any idea? If we have to find, if suppose here also minus will be there, then definitely we would go for checking beta also. So what we are supposed to do for that? We can see here this line is passing through negative 2, not negative 2, positive 2, 1 and negative 2. Can we say x1, y1, z1? This line uh, is passing through this point. Yes or no?
Yes.
And the same point will lie on the plane also, right?
Yes, ma'am.
Obviously, line is on the plane. So the point which we have taken out from the line, that point will lie on the plane also. So here also we will substitute 2 plus 3 minus alpha, we have got negative 6. So that will become positive and again negative 2. That means 12 plus beta. So here we can see 6 minus 12. Are we getting? Okay, 5 minus 2. Sorry. Yes, we are getting the right option is the option A. Okay. Is it clear? If we have to find beta, how we will go ahead? Is it clear? See what we have done. We were having a plane and a line, and the line is lying on the plane. Okay, line is lying on the plane. So we have just made the normal to the plane, and we are saying that normal will be perpendicular to the line. And we are using the condition of perpendicularity, and then we are just finding the value of alpha. And by using the point from the line, we are also able to find the value of beta. However, we don't have to find beta. We will obviously every time we will keep our eyes on the options also. So no need to waste time. Okay. Okay, let's proceed to the next question. Next question is two lines L1 x equals to 5, y z 1 negative 2, and L2 x alpha y 1 z 2 minus alpha Yesterday also we have solved the few questions where we were having the lines were coplanar. Then we have to find the value of alpha here. Then alpha is equals to. Okay, options are given over here. Options are 1, 2, 3. So what we do when we are having two lines which are coplanar? At first our equation of a line, let's just do a little bit of arrangement over here. Here it is x equals to 5. So we can write it as x minus 5 over nothing is there. So just to keep it clear, we are writing it like this. Okay. However, whenever we are having something like this, we have to write our equation of a line the way it is given in the question. But to make it more clear, we are writing it, for now we are writing it like this. Y 3 minus alpha is equals to, just z. Okay, y nothing is there, so 0 we can say, z minus 0 we can say, over negative 2. This one is one of the equation of line, and the other one is x minus alpha 0. Here options are not given. Okay, the options which I have written here, by mistake I have taken the option from the different question. X minus alpha by 0, y minus 0 we can say over negative 1 is equals to z minus 0 over 2 minus alpha. This is what we are having our equation. Okay, if these two lines are coplanar, then what we will write? By using the determinant, what can be written? Anyone? Previous day also we were solving one question like this only. Yes or no?
Ma'am, can you repeat?
Yes, what determinant?
Can you repeat?
Yes. So if I am writing the determinant, what shall be the elements, the terms over here?
I, J, K.
Sorry, your voice is not clear. Was it x2 minus x1, y2 minus y1, z2 minus z1, oh, and here a1, b1, c1, a2, b2, c2, like that
Yes, ma'am.
is equals to 0, right? Let's do that and let's see whether it is possible to find alpha from here or not. So x2 minus x1, these are x1 y1, this is x1 y1 z1, x2 y2 z2. Okay, let's do that. So we will be having x2 minus x1, that means alpha minus 5, then 0 minus 0 0 0 minus 0 0. Okay, minus alpha, and here negative 2, again 0 negative 1 2 minus alpha. This is what we are having is equals to 0. We have to compare. Now we just need to solve this determinant. Thankfully the other two elements are just 0, so we will be taking the first element from the first row and we are done. So we will be just taking alpha minus 5 and then crisscross we will do. That means 3 minus alpha, 2 minus alpha, and then minus, this will become plus, minus 2 is equals to 0. So what we are having, alpha minus 5, let's keep it aside as it is, because we will have to find the value of alpha. So basically we will try to do the factorization over here. If already we are having a factorized form, that is alpha minus 5, well and good. Let's keep it aside as it is. So what we'll be having after that? We need to simplify the curly brackets. So we will be having 6. We will be having minus 3 alpha minus 2 alpha plus alpha square minus 2, like this, is equals to 0. After this, we'll be having alpha minus 5, 6 minus 2, 4 plus alpha square. This is what we are having is equals to 0. That means alpha square minus 5 alpha plus 4 is equals to 0. Alpha minus 5. Let's do let's split the middle term. So we'll be having alpha square minus 4 alpha minus alpha plus 4 over here. That means alpha minus 4 and alpha minus 1. Okay. Alpha minus 5 is already there. So 4 1, we needed to find the value of alpha over here. So according to the option, we will be selecting 5 4 1 over here. These are the possible values of alpha. What we have done here, just the coplanarity condition we have used, but the equation of line, just we have arranged at first to keep it clear that what will be x1, what will be y1, what will be z1, and then a1 b1 c1 a2 b2 c2. So we have just we have done the arrangement over here, and then everything is same like the previous day's concept. Okay, is it clear?
Yes, ma'am.
Is it clear to everyone? Let's take the next question. So one of the question is the equation of the plane which contains the y-axis and passes through the point 1, 2, 3 is, options are x plus 3z is equals to 10, x plus 3z is equals to 0, option C 3x plus z is equals to 6, and option D 3x minus z is equals to 0. Okay, let's see what the question says. Equation of a plane. Equation of a plane which contains the y-axis and passes through this point. Okay, so we know that equation of a plane passing through a certain point and having direction ratio, passing through this point and the direction ratio, if let's say direction ratio is a, b, c. So equation of a plane will look like, can you tell me what will be the equation of a plane having direction ratio ABC and passing through this point? Let me know. Yes, What will be the equation of the plane? Having direction ratio ABC passing through point 1, 2, 3. Can we say equation of plane will look like this? A x minus x1 plus b y minus y1 plus c z minus z1 is equals to 0. Yes or no? Can we say this is how our
Yes.
equation of plane will look like?
Yes, ma'am.
X1, y1, z1 over here is 1, 2, 3. So we will be having a x minus 1 plus b y minus 2 plus c z minus 3 is equals to 0. This is our equation of a plane. Now the equation of plane which contains the y-axis. Equation of a plane contains the y-axis. So this concept is also same like that. If we will be taking a normal to the plane, that normal will be perpendicular to the y-axis also. If we will take normal to this plane, okay, let's see what will be the normal to this plane. How to take the normal to the plane? First we will be taking ax plus by plus cz, here negative a, negative 2b, negative 3c. Okay, so normal to the plane will be x coefficient with I cap, y coefficient with j cap, and z coefficient with k cap. This is the normal to the plane. Now this we are saying will be perpendicular to the y axis also. So we know the direction ratio of y axis is 0, 1, 0. Okay, that means if we will take a into 0, dot product will be 0, right? Since we are saying both will be perpendicular, yes or no? Yes or no? Let me know. So we will be taking a into 0 plus b 1 plus c again 0 is equals to 0. So we got b is equals to 0. Okay. Our equation of a plane which was this one, or we can say which was this one, this equation 1. Here p is 0. Okay, we can take the previous one only, no need to just keep it expanded. This one we can do rectangular one. So here b is 0. We can now our equation of plane will look like a x minus 1 plus c z minus 3 is equals to 0. Okay, now what we have to find? The equation of plane only. Here we can see x plus 3z, a b we know b value is 0, but we don't know anything about a and c. Since the equation of a plane contains y-axis, can we say, since the equation of a plane contains y-axis, can we say here x coordinate will be 0 and z coordinate will also be 0, whatever be the y coordinate, but x and z coordinate will be 0 on the y-axis. Yes or no? Yes or no? So x coordinate will be 0, z coordinate will be 0. So what are we getting here? We are getting minus a minus if this is 0 and that is also 0. So still we are getting minus a minus 3c is equals to 0. We can say a is equals to negative 3c. Okay, if we will be substituting it in our equation of a plane, that was b0, a is equals to minus 3c. Let's substitute it, this equation here. Okay, here a is minus 3c, b 0, c will be c only, z minus 3 is equals to 0. Let's just divide both side by c, or take c as a common and just transfer it to other side. C is just a constant. So we will be having minus 3x over here plus 3 over here, and here we will be having plus z minus 3 is equals to 0. So what are we getting? We are getting minus 3x plus z is equals to 0. Let's see that option is there or not. Okay, let's make it plus 3x. So it will be plus 3x minus z is equals to 0. Option D is the correct option. Can you see what we have done? Let's just have the summary. So equation of a plane which contain y-axis. If we will take the normal to the plane, that normal will be perpendicular to y-axis. That much we know. What will be the equation of a plane? We know how to construct the equation of a plane passing through a point having direction ratio ABC. So we have written the equation of plane over here. After writing the equation of plane, we are doing the dot product and we are equating it with 0. From there, we are getting B as a 0. But we don't know what is A and C. So we know one condition, that equation of a plane which contains the y-axis. If we are talking about any point on the, let me take any point on the y-axis. So the point must be x coordinate 0, y coordinate will be whatever be the number, and z coordinate will be 0. So x and z coordinate will be 0. Such a point we will get. Whatever point we will get on y-axis, that point will look like this one only. X coordinate and z coordinate 0. So in our equation where we have got b as a 0, this equation we are here we are substituting x as a 0, z as a 0, and we are getting one relation in between a and c. Now again we are just substituting the relation in our equation of the plane, and we are getting the equation of a plane as one of the option. Is it clear to everyone?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Okay, let's move ahead. One of the question, these are the recent question. Okay, 2019, 20, 21, 18, 19. So the equation of the planes parallel to the plane x minus 2y plus 2z minus 3 is equals to 0, which are at unit distance from the point 1, 2, 3 is ax plus by plus cz plus d is equals to 0. If b minus d is equals to k times c minus a, then the positive of k is, okay, let's do it. The equation of a plane parallel, the equation of plane parallel to this plane. If we have to assume a equation of a plane which is parallel to this plane, can you tell me what we will assume? What can be the assumption? Let me know what can be the assumption. can we say our equation of a plane here coefficient, here coefficient, here coefficient, everything will be same except this d. So equation of a plane which is parallel to this plane will be x minus 2y plus 2z plus d will is equals to 0. Can we say this plane is parallel to this plane? Yes or no? Yes or no? Recall that in 2D you have learned the rule that if two planes are parallel, their slope has to be same. That means there was a condition A1 by A2, B1 by B2, C1 by C2 and all. Yes or no?
Yes, ma'am.
Similarly, here also we can use the same condition. The coefficient, this A1, A2, B1, B2, C1, C2, this coefficient will be same, D will be different. Okay. This is how the equation of plane which is parallel to this plane will look like. Now let's read the question. The equation of a plane parallel to this plane, which we have assumed already, which are at unit distance from this point. Okay, so the rectangular plane which we have taken by ourselves as an assumption, that is at unit distance. Distance is unit means 1. From which point? From 1 to 3. We know how to find the distance from a point to a plane. So let's find the distance from point 1 to 3, and the equation of plane we have taken as x minus 2y plus 2z plus d is equals to 0. So distance will be ax1 plus by1 plus cz1 plus z plus d over a square b square c square. So ax1 that is 1, by1 that is this, cz1 that is this, plus d over under root a square plus b square plus c square. Mod of that is equals to unit distance means 1. Okay, let's simplify it. So we will be having 1 minus 4 plus 6 plus d over 1 plus 4 plus 4 is equals to 1. We will be having 6 plus 1, 7 minus 4, that is 3 plus d in the numerator, and the denominator 9, that means 3. So d we are getting as a 0, right? We are getting d as a 0. Yeah, 0. This 3 will go over there. Have we done the calculation correctly? 6, 7. Yeah. Yeah. Now our equation of plane will be what we have taken, x minus 2y plus 2z, x minus 2y plus 2z plus d is 0 is equals to 0. This is our equation of required equation of plane. Are we supposed to find the equation of plane? So which are at unit distance from this point is, this is how our equation of plane will look like. If b minus d is equals to k in bracket c minus a, if b minus d, if b minus d is equals to k in bracket c minus a, then k value we have to find here. What is b, what is a, what is c? This is the equation of plane, that is ax plus by plus cz plus d is equals to 0. We will compare. A is 1. Okay, so here we will be writing 1. B is minus 2. Here we will be writing minus 2. C is plus 2. So here we will be writing plus 2. D is 0. Here we will be writing 0. Here K. This is how we need to do the calculation to check what will be the value of K. Let's see what will be the value of K. So 2 minus 1, 1. K will be negative 2 only. This is our answer. This is the value of K. Okay. Let's summarize. Equation of a plane parallel to this plane. Equation of a plane parallel to this plane will look like this one. Okay. ax1, by1, cz1, d. A, B, C all will be same. Okay. Coefficient of A, B, C will be same. I mean D, we don't know, we have taken this plane as an assumption. Now this plane is at unit distance from this point. So we have applied the distance formula. That's it. We were able to find D. We got our equation of plane. Now we just have to do this calculation. Okay. Is it clear? Yes or no? Here, if we will see, says that b minus d is equals to c minus a, then the positive value of k. Okay, it says options are not given below this question. So it is asking for positive value of k. So if we will take here plus minus sign, either it will be plus or it will be minus. The modulus of 3 plus d is either plus 3 or 3 plus d, or is it equals to minus 3. So d we got either 0, either we got d as a 0 or we got d as a negative 6. Okay, if we will take negative 6 for d, so minus of minus 6, that means plus 6, and we are getting positive answer from here. 6 minus 2, that is plus 4. Okay, I believe this one must be there in the option. K value is 4. Is it clear now? Any confusion over here? Yes or no?
Yes, ma'am.
Let's take another question. So if the question is, let the plane ax plus by plus cz plus d is equals to 0, bisect the line joining the points 4 minus 3 1 and 2 3 negative 5 at right angle. Just a moment now. Let me share it again. Yeah. So our question was, let the plane this one bisect the line joining the point 4 3 negative 1 and 2 3 negative 5 at right angle. If a b c d are integers, if a b c d are integers, then the minimum value a square plus b square plus c square plus d square we have to find is, let me check the options. Options are 30, 28, 29. Okay, let's do it. So let the plane, this one, bisect the line joining the point this and this. Okay, the plane is bisecting the line. If there is a, this is a point P and this is a point Q, let's understand what the question says. The plane is bisecting the line. That means PQ is there, PQ is there, and the plane is bisecting it. Plane is bisecting it. Okay, the line. Bisecting means cutting in two equal parts. Okay, at right angle. It is bisecting it at right angle. So here, if we will take any point on PQ, can we say the midpoint of PQ? The midpoint of PQ, that is, let's take I on this plane. Can we say the midpoint of PQ will lie on this plane? How will find the midpoint of PQ? Please find it. Please find the midpoint of PQ and let me know. We know 2, 3, -5. The coordinate of P is known to us. The coordinate of Q is also known to us. Please find the midpoint and let me know what are you getting. Just a second. Find the midpoint and let me know. No, just what you got as a midpoint. Yes, anyone, have you found the midpoint by using the midpoint formula? A1 plus A2 by 2, B1 plus B2 by 2, C1 plus C2 by 2. The formula which we used to, which we were using in 2D, same formula is there for 3D also, right? What you got? What's that? Anyone? Have you found? 4 plus 2 by 2, 6 by 2 is 3, right? Minus 3 and then plus 3, that means 0 by 2. 1 minus of minus 5, that means 6 by 2, that 303. Am I making sense? We are just finding the midpoint of PQ. Have you found midpoint? Is it 303? Please check the calculation. Check it. So this, now we can say this plane, let the plane AX plus BY plus CZ plus D bisect the line joining. We are saying this point M this point M is lying on the plane. Since the plane is bisecting the line, now we can write the equation of a plane which is passing through M. Okay, M is 303. Yes, someone, yes, 303 everyone is getting. So we will be having the equation of plane passing through this point. Now only we have discussed A x minus x1 plus B y minus y1 plus C z minus z1 is equals to 0. Okay, these are the A, B, C are the direction ratio. Now it is written over here that PQ is at right angle. Okay, so direction ratio of PQ also we can find by doing x2 minus x1, y2 minus y1, z2 minus z1. Let's find it. So x2 minus x1, if we will do 2 minus 4 minus 2, that means 2, negative 3, negative 3, negative 6, 1 minus of minus 5, that is again positive 6. If we will divide all by 2, we will be having 1 minus 3, 3. Yeah, 1 minus 3, 3 we will be having. We can say A into 1, 3 plus C into 3 is equals to 0, right? Here what we have to find? The minimum value of A square, B square, C square, D square we have to find. Okay. So first we must find the equation of the plane. Just a moment. Alright, we can use the direction ratio of line PQ, 1 minus 3, 3. If we will generate the equation of a plane by using this direction ratio, we'll be having x minus 3, we'll be having negative 3, y minus 0, we'll be having 3, z minus 3. From here we are getting x minus 3y plus 3z minus 3, 0, minus 9. Minus 3 minus 9 is minus 12 is equals to 0. If we will compare it with ax, by, cz, d, we are getting a as a 1, b as a negative 3, c as a positive 3, and what about d? D we are getting as a negative 12. D square, c square, d square. Let's do that. So 1 is square, 1 is square, b square is minus 3 square 9, c square 3 square 9, d square is 12. Okay, 12 is square if we will do. But this is becoming larger and the options are smaller. Just a moment. With the plane ax plus by plus cz plus d bisect the line. So we are finding the midpoint and we are saying that our plane is passing through this midpoint. Okay, 303. Have you checked this midpoint is correct or not? 303. Check it first. The calculation, please do it with me. Check it whether 303 is correct or not. The numbers, let me check in the question. I have written it 4 minus 3, 1, 2, 3, negative 5. Midpoint, are you getting 303? X1 plus x2 by 2, you are doing it. A1 plus x1 plus x2 by 2. So 3 plus 4, 6 by 2, 3. Minus 3, plus 3 0, and 1 plus minus 5. Okay, it is giving minus 4 by 2, that means negative 2. Okay, no one said to me that here we are getting minus 2, not 3. Yes or no? So we have to change our equation of the plane. It was minus 2. That means plus 2 we will be having here. Z minus 3, no. Z plus 2 we will be having. 3, 2 times 6 we will be having. Are you doing calculation with me? This 3, 2 times 6 we will be having, and here we are having minus 3. 6 minus 3 is 3 only. Let me check. Now we are getting or not. A1 plus B, A square, B square, C square plus D square is 3 square. 9. 27, 128. 28 we are getting. Are you getting it? Are you getting what we did? We are saying since the plane is bisecting the line, let's take the midpoint and let's find the equation of the plane. Once we are getting the equation of the plane by using the direction ratio of the line, which is at right angle. Okay, direction ratio of the line we are using to create the equation of the plane, and this point we are using to create the equation of a plane. Once we are having equation of plane ABCD we are having, we just have to find A square, B square, C square, D square, and that value only will be the answer. Is it clear? It is 303. Still it is 303 or 30 minus 2. Please check it. The points are 4 minus 3 1, and the other point is 2 3 negative 5. We are doing A1 plus A2 by 2, B1 plus B2 by 2, C1 plus C2 by 2. That's it. Have you checked? What are you getting? 303 or 30 minus 2? Anyone?
-2.
Exactly. We will be having minus 2. Okay. Now is it clear? The question, the solution?